You can think about parameterizations this way. Here's our UV plane, and U is bounded by A and B, and V is bounded by C and D. C and D are constants, A and B are constants. And as we move along the parameterization, whichever direction you move along, each point in the UV plane gets mapped to a point in the space XYZ, so R3 over there, and you move along the surface, okay? So even though you're getting mapped into R3, you're really just sticking onto the orange surface that you see over there. So here's a simple parameterization of a cylinder, okay? If you have a fixed radius A, so treat A like a constant, okay? It is the radius of the cylinder. And U is this theta, right? You could think about it as our traditional theta. Here we're calling it U. It's a complete other variable, but that's how you could think about it. And V is our traditional Z. So you're moving along. V equals Z, and U equals theta. Now as we move along the UV plane, look what happens. So this blue line gets mapped to that blue line. You're staying at you're moving around the cylinder in a circular way. If you hold V fixed and vary U, the angle. And on the other hand, you could hold U fixed, okay, and vary V. V is Z, so you're moving up and down the cylinder, okay. So we could do that at different points. We can move up and down the cylinder along Z, or we could just move at a fixed Z along the cylinder in a circular manner. And each of these points is getting mapped to a point in R3 that's on the surface. Another popular parameterization here is the cone, okay? And here we're parameterizing using Z, which we'll set equal to V, and the angle, which we set equal to U, okay? And you could see how this works. So if we move up and down V, which is equal to Z here, we're moving up and down the cone. And if we move left and right along the blue line, we're moving around the angle, okay? And so there goes a parameterization for a cone. Here's another popular parameterization, and this is of a sphere of radius A. Again, A is fixed here. And we could use, you could almost think about it as borrowing from spherical coordinates, the U being equal to phi and V being equal to theta. So U being the polar angle, okay, the angle that goes from the North Pole to the South Pole, starts at 0 at the North Pole and goes to the South Pole at pi, and V going around the whole circle from 0 to 2 pi, okay? So take a look at how this green line gets mapped up. Okay, here we're moving around a given latitude, if you will. Okay. And we could also move along the polar angle, going from North Pole all the way out here to the South Pole at a fixed longitude. Okay. And everything in between, right? Depending on what U and V you choose. The important thing is that each of these points gets mapped onto the sphere of radius A, and that this sheet in the UV plane actually maps to the entirety of the sphere.